examples and the overall idea of the conditional probability. Okay, so we have to talk about two different types of events first: independent events and dependent events. So independent events are like tossing two separate coins. So if you toss one coin, the probability of being a head or tail is 50-50. Okay, so 0.5, and then if you toss another coin, the outcome of that head or tail does not depend on the tossing of the first coin. Okay, so they are independent events. Similarly, if you randomly pick two persons from the US population who have blue-eyed completely randomly, okay, so then so that is an independent event. So occurring of, I mean, they are said to be independent. If one event has occurred, it does not affect the probability that the other event will occur. So you pick one person, may or may not have blue eyes. You pick another person, may or may not have blue eyes. Because you choose the first person is not necessary the second person will also have blue eyes or something like that. So they do not have any relation, or they do not impact each other, does not affect each other. Okay. So on the other hand, dependent events are something you do perform one and that impacts the other event. Okay. So in that case they will be called dependent events. So the probability of the first event will impact the probability of occurrence of the second event. Let's consider some examples. So drawing an ace from a pack of 52 cards. Okay. So if you try to draw an ace from a pack of 52 cards, or you try to draw a queen from a pack of 52 cards, it's a dependent event. Why? Because initially there are 4 aces or 4 queens in a pack of 52 cards. So once you draw the first one, initially the probability will be 4 divided by 52. But once you have taken that card and you have not replaced it, so then for the next event, if you want to draw another ace, there will be 3 aces now and there will be 51 cards. So the probability has changed given the fact that the first event occurred. So you see, these are like one event impacts the other event. So let's see an example. So in a class there are 23 boys and 25 girls. Okay. So now from them, let's choose 2 students such that both of them are girls. Okay, both of them are girls. So how would you do that? You see that this is a dependent event. So because why? Because the probability of choosing the first girl or the girl 1 is like 25 divided by the total number of students, which is 23 plus 25, like 25 divided by 48 for girl 1, the probability of choosing girl 1. Now the probability of choosing girl 2 will change depending on the outcome of the probability of choosing the first girl, because you have chosen a girl, taken her out of the pool, and you have not replaced her. So now there are 1 less girl and 1 less number of student. Okay, right? There are 24 girls, 23 boys, and total 47. So there's for girl 2 the probability is 24 divided by 47. So what is the, now use the conditional probability formula, which is the conditional probability formula is probability of A given the fact or given the knowledge that B has happened is probability of A intersection B, that means both A and B happened, divide by probability that B has happened. Or the other way, if you can consider B given A has happened, similarly it will change. Okay. So now probability of having 2 girls, that means a girl 1 and girl 2, probability of having these 2 will be calculated using manipulating that formula, that it will be basically probability of A given B, that means the dependent event probability multiplied by probability of B. Okay, that means so now you see probability of girl 1 times probability of girl 2 given girl 1. So that is the probability that girl 1 and girl 2, that means the 2 students selected are both girls. So this and is also represented with the set intersect formula. So notation. So you see this is so this is also called joint probability, the and. Okay, intersection of 2 or more events. Intersection of 2 or more events are called joint probability. So it's written as A intersect B. So what is this? This is basically the likelihood, the probability that let's say an example. Let's say a card is black and 7. Okay, so there are two 7s of black cards, which is of spades. We get the naive Bayes algorithm from these two equations we just got just seen. So probability of A given the fact that that B has already occurred is probability of A intersect B divided by probability of B. Okay, and similarly probability of B given A is just probability of B intersect A divided by probability of A. Now if we multiply it and we find okay, probability of A intersect B in both sides we equate, you can see probability of A intersect B and probability of B intersect A means that two events happening together. Okay, so probably A and B basically. So basically they are same. If we equate this two, then this left side from this equation and right side from this equation can be equated to write that probability of A given B equal to probability of B given A times probability of A divided by probability of B, which is basically the Bayes rule, okay, designed by Thomas Bayes. So now you see here, probability of B given, this is called a posterior probability, we have already talked about it. This probability of B given A is called likelihood, and probability of A is called the prior probability, and probability of B is called the marginal probability, okay, depending on the other side. So you will have another equation, or you can have probability of B given A equal to probability of A given B times probability of B divided by probability of A. In that case, the terms, the name of the terms will remain similar and corresponding to that, the numerator denominator, and we'll take it from there.